Welcome to Aria's Science Tutorial channel, where we have a passion for simplifying the teaching and learning of science and mathematics. Thank you very much for deciding to tune in, and as you watch the video, follow the lessons. If you find it interesting and educative, please don't forget to subscribe, like and share with others, family members and friends. All right, now that I know you've subscribed, let's get the ground rolling. Okay, in this YouTube, we shall be looking at a topic called the basics of electrolysis. The basics of electrolysis. Electrolysis is actually one of the important concepts in chemistry that plays a lot in making life modern and interesting for us. However, at a later video, we shall be looking specifically at the uses of electrolysis. In this video, we want to concentrate on the basics of electrolysis. So, basically, electrolysis is a compound word that is made up of two components: electro and lysis. Electrolysis is made up of two components, electro and lysis. The word electro comes basically from electricity. Electricity. Yes, electro means electricity, and lysis is the Latin word for breakdown. Breakdown. So, essentially speaking, it means that if we join these two components together, electrolysis basically means the breakdown of certain substances by passing electric current through them. All right, I know you'll be interested in finding out, is it any kind of substance that we can pass current through, or there are certain types of substances that we'll specifically be interested in? All right, let's assume we're in the kitchen now. Now in the kitchen we have the kitchen salt, which I'm sure everybody is familiar with. Okay, if I take a spoon and I scoop some kitchen salt, which by the way is basically sodium chloride, I'm sure you know that. Okay, now I could decide to take the sodium chloride, which is my kitchen salt, put it in a frying pan and heat it to a very high temperature so as to melt it. Okay, if I do that, I will say I have molten sodium chloride. On the other hand, if I take the sodium chloride and dissolve it in water, I would have created an aqueous solution of sodium chloride. All right, now what's the big deal about the three different forms of the sodium chloride I've talked about? Well, basically, in both the solid, the molten, and the aqueous form of the sodium chloride, there are ions, oppositely charged ions, sodium positive and chloride negative. The essential difference is that in the solid form, the positive and the negative ions are not free. They are locked together by a strong force of attraction. In other words, the ions are not mobile. However, in either the molten or the aqueous form, the heat that we've used to melt the sodium chloride ensures that the ions are free. They are mobile. While in the aqueous form, the water that we use in dissolving the sodium chloride has also made